Okay, hello all. Welcome to the ST Scales weekly system design session. Today we are doing a mock interview, and Chaitanya is the interviewer, and Abhishek is the candidate. So they would be discussing for a question for another 45 minutes to 50 minutes, and then we'll open for the audience for the discussion for any points, any recommendations, anything could be done different. So I'm giving the podium to Chaitanya and Abhishek now. Yeah, Chaitanya, you can start.
Yeah, sure. So thanks for the brief intro. Yeah, before we start the interview, could you please introduce yourself, Abhishek?
Yeah, hi, I'm Abhishek Agarwal, and I have 6 years of experience in software development. I have worked at various stacks of software. When I joined the industry, I was working on the UX, and then I started working on applications and all. And recently, I have been working on large-scale distributed systems where I'm involved in building the search systems for document search. So yeah, that's about me.
Okay, cool. So today we will mostly design a system that is used to send notifications. So in short, it's a notification service or system that I want to build.
Hmm. Okay, so we want to build a notification system. And what kind of notifications are we talking about? Like, who are the users? What is the?
Yeah, so generally this notification systems is already a part of subsystems present in a lot of big applications. Like for example, um, if we do a bank transaction, we get a notification.
Mhm.
Uh, I purchase something from Amazon, I get a notification for that, and so on. So um, yeah, I mean, I want to build a system that will handle all kinds of notifications.
So we are going to provide that infrastructure that using my system, someone can build their notification system. So I have to build that notification system and then I can say that you can use my system if you want to add notifications to your application, right?
Correct. Yeah.
Okay. So got it. Okay. Right. Okay. Uh, mhm. So, so, s- so starting with requirement, we want to build the infrastructure for applications to leverage notifications. Um, and okay, and so these notifications, are they going to be like on some? So the clients. So basically, the clients would be subscribing. So it would be someone would be publishing the notification, right? And the clients would be subscribing, and whoever is the subscriber, they will get the notifications whenever something has been published, right?
Right.
So
So
mhm.
yeah, I mean, we can think of this as um, uh, some kind of an API service wherein through our product we expose these APIs, and there's a pay per usage for this system.
Okay, got it. So we have right. Okay, so we are creating these APIs. So these APIs would be for a publisher uh, to publish uh, messages to notification system, and for subscribers to get notified
Yes, correct.
for these messages, right? Okay. Okay. Great. Okay. Uh, yeah. Okay. And so, and just to understand the scale, so what are we going to say to our clients, that what is the scale that we are going to support?
Okay, to start off with, I have an initial requirement of minimum 10 million notifications per day.
Mhm.
And
10.
yeah, minimum, yeah, and it can grow up to, let's say, 100 million per day.
So 10 million notifications and okay, 10 million notifications per day. And the size of the messages, are there any restrictions on the size, that what will be the size, what is the maximum size of each notification?
Yeah, right now we can go with a very minimal approach of, let's say, just 1 KB per message.
So 1 KB per message. And what about, so could there be multiple, like, could there be multiple subscribers for the same message, or is it like one to one, like, so one message would be sent to only one client?
No, actually there can be multiple notifications. So either let's say there's a promotion event, so that promotion event can be sent to hundreds of or thousands of people who are there in the system of the client.
Okay, so it's like one. Okay, so it could be one to many notification system,
Right.
right?
But on the other hand, we can
Or
like
mhm.
yeah, sorry, I'll just complete. On the other hand, let's say I purchase something from Amazon, so only I get the notification for whatever I've purchased. So
So I yeah, it could be either one to one or one to many. Okay. Mhm. And okay, and okay, and I believe, and what if I, so should my system be like, so, and what about the ordering of messages? Is ordering important? Is the ordering of notifications important for my system?
yes.
So ordering is important. Okay. And what about the, like, if so it, so to, if I have to dedupe the message, if the client has not got my notification, yeah, so like, how long am I going to keep the message with me? Like, if, let's say, uh, the client to whom I have to deliver the notification, if it was not available, so then up till how long I have the responsibility of holding the message?
I mean, initially we can consider the time to live for that message to be 1 day.
Okay, so then I will try to deliver that notification for 1 day, but if within 1 day the client was not available, then I can just discard the message, right?
Yeah.
Okay. So okay, got it. Okay. So, and okay, so now let's, coming to scale, we discussed that the system will support 10 million. So if we look at the size per day, so this is the like, this is the scale of data, right?
Yeah.
That 10 million. And what is the scale of, like, kind of compute, like how many requests would we be getting from, I think the request would be 10. So these are the 10 million notifications that are generated by the client, or they, like, these are my subscribers who would be getting this
No,
data?
our systems will be getting 10 million API calls per day.
10 million APIs called to publish the message?
Yes. So
Uh,
that
mhm.
message can be
So
delivered.
then I have at least 10 million publishers per day, and mhm.
Yeah, correct.
And it will be delivered to like up till how many users? Like, what is the scale of that?
We can take 100 million users,
Okay, so estimate is
because some messages out of 10 million might be delivered to hundreds of people. So
mhm. Yeah.
and or else we can ramp this up to maybe 1 billion, also 1 billion subscribers.
Okay. Yeah.
Also, one thing I would like to add here is the people who are, or the publishers who are calling our system. uh, there might be some messages which are having high priority. Like, for example, while doing a bank transaction, I get an OTP. So priority is an important thing which
Oh, okay. Okay. Yeah, that's okay. So, but how will the priority be decided? Like, is the priority among messages or is the priority among clients that we're talking about here?
priority among messages. So the publisher will tell us how, with what priority he wants to send that message, and based on that we will charge the client.
Okay. But still, okay, okay, just so a question here. If let's say I say this message is high priority, right? And
Yeah.
then the second message which I'm publishing is lower priority, right? And uh, so then what about ordering? Because the message which is high priority, we are saying it has to be delivered faster, right?
Yeah.
And then what about ordering? Let's say my lower priority message, the request was generated first, and the higher priority message, it came later. So then how will I decide the ordering? Because we also said that ordering is important.
Yeah. I mean, ordering is important for from a priority perspective. So let's say if there are two messages of high priority, then whatever those two messages are there, they of high priority, they must be delivered in the same order. But of a low priority, we don't. I mean, it can come in 1 hour also. Maybe it might be some kind of sale event. Some kind of message saying that there's some offer or something. So that is not an important or high priority message for me.
So is it like, are we saying that when a client like when a client subscribes to my API, so he will initially, when he's setting up at that setup, he will say that what kind of messages I will be using my notification system for, right? If the client is saying that my system is a high priority system, right? Then I will say that uh, the latencies with which your notifications will be delivered will be lower latency. I will be guaranteeing him lower latency because you're saying that you want high priority messages, and I will charge him more money, right? And then
Correct.
another client, another client or same client, he might say that I'm also subscribing to this message service, but there is this second kind of messages that I want to send, which are lower priority, which are sales and promotion. So I will charge him lesser money for that, but the latencies might be more, right? This is
Correct.
what we're saying. Okay, got it. Okay, right. So client can specify the priority of messaging. Okay, so yeah, so let's go into the scale. Okay, so let's move into the size. So the size of the data per day that we are generating would be uh, 10 million, which is 10. Let me use my pen now. Okay. So 10 million right into 1 KB, which is equal to, we said 10 million right here, 10 into 6 into 1 KB. So which is kilobyte, megabyte, KB. So this will be megabyte, this will be GB. So every day we are generating 10 GB of messages, right?
Right.
Is my calculation correct? So 10 GB of messages, and because we are saying that we will be keeping messages only for a day, so overall our system will never have the messages which are more than 10 GB, right?
No, I mean, if the message is not delivered in one day, I mean, we need to keep a track of, like, tomorrow if some kind of client comes to me and says that the message was never sent to the end user, so we should have this information in our system saying that, hey, I mean, we send it to the user at this particular time using this particular mode, let's say SMS or email, or I mean whatever maybe the notification kind. So we need to store all this data in our systems.
So this data will always be persisted, but it will so it will always be persisted somewhere, that if, like, say for audit purpose or some purpose, if we want to get the data, this data will always be available. Is that what you're saying?
Right, because at the end of the month, if the client is coming to me and asking me to justify the payment or the charges that I have asked him to pay, I should have a record on my side saying that, okay, we sent these many messages to these many people.
Okay, but we are saying that we will persist the message, but our delivery responsibility is only for a day, right? We will retry only up till a day.
Right.
Is that the same thing? Okay. Okay, so then this is one more requirement, that messages are kind of like archived or something. They're always stored for audit later. Okay, so my queue will have this much size of message. Okay, and then later at the end of the day, I can move these messages to a lower and to a cheaper storage solution where they can be pulled out later if we want to do any audit or if we want to do something. So so I think still that part is independent, because that could be a background process running, getting these messages, which are 10 GB messages, and storing them on like some hard disk or some tapes or somewhere where these messages could be persisted. But overall, from the notification system, I have to handle 10 GB of messages. 10 GB of messages, they could probably fit on a single machine. And let's look at the request. So we will be getting 10 million. Yeah, so we will be getting 10 million requests per day, right? Which is how many requests? So which is, if we do 10 into 24 and into hours, and then minutes and seconds. So let's do 24 into 36. Okay, anyway, so let's simplify it. So 10 to 5 36 into 24. So this could be 70. It's 36 into 24, 860. So, okay, so around 115 requests per second.
Yeah.
This is on the subscriber end, and publisher would be 1 billion, right? So which is into 100. So 115 into 100. These are my subscribers, right?
Into 1,000.
Yeah. It was 1 billion, so into 100, right?
Yeah.
Because 10 million to 1 billion. Yeah. Yeah. Okay. So overall, I see that my system could have these things could be like the number of requests are very high, and the subscribers are a lot, which could be handled by a single system, right? So I would build a kind of a distributed system. And so overall, my high level design would look like this, that internally I would be implementing a queue kind of a system where a subscriber would be sending my messages to the queue, right? And there would be various publishers to whom I will be sending notifications about the incoming message, right? So basically, I have to implement a distributed queue, right?
Yeah, more or less.
More or less, right? And okay, so okay, so I have so so basically so let's see how will I implement this distributed queue. So so first thing is that I want to partition this data so that uh, these requests could be handled by multiple nodes, and I will also replicate my nodes. And then like I will have some DB I can use. So so I'm assuming, since we have to implement, so can we take a dependency on these queuing services like Apache Kafka or something, or we are building our own queue? Because I think that queue is the main component here, right? So
Yeah, sure. So we can use uh, the already built tools. So we can rely on Kafka here.
okay, so we can rely on Kafka. Okay, great. So then the things become simpler. So then basically, yeah. So then basically most of the things could be done by Kafka. Uh, so like, so basically my system would look like this, that I will get a request, right, from the client. And I will put the message in the, so this is, let's say, my application server. So this application server will talk to this queuing service.
Yeah, will the client directly call the application server, or I mean, is there just one application server or multiple instances
Yeah,
of?
no, yeah, there will be multiple application servers. There will be load balancers, which will be dividing the load across various application servers.
Mm-hmm.
Yeah, so that will be there. Um, then the application server will handle the request. So I'm assuming what the application server can do is it can put this message in the queue, right? Which will be handled by Kafka like service, which will be used for notification. And then asynchronously, it can also put this message in a storage system, like a DB or something, where this message will be persisted for this audit purpose and all those things, right?
Okay.
And right,
But
and
yeah, sorry, just one question here. So as a client, when I'm calling this application server, uh, what kind of response will I get? Will I get a response that the message has been sent, or I mean, how will I know from the response what has happened?
so yeah, I think from the response, the response should be something that your message has been uh, like your message has been persisted with us in the queue, but then uh, it actually being notified, that depends on the client being available at that time. And so are we saying that when the message is delivered to client, then the publisher should be known about it? Or
Yeah, I mean, I'm trying to understand whether for the client, is it a blocking call that he'll wait for a few seconds and then he gets
no, I think he will just get a response back as soon as the message is returned to the Kafka queue, and then he don't have to wait for the subscribers to actually for them, uh, right? So he does not have to wait for them to for message to actually get delivered. He will be just returned successful as long as I have kept the message with me, right?
Okay, yeah. So I mean, from a client perspective, it's a bit I mean, it's asynchronous
Yeah,
communication between
yeah,
them.
it's asynchronous call.
Okay,
Yeah.
so the client will just get some information that okay, we have noted your message and we'll process it.
Mhm. But before that, I think so there will be one setup, right? So I think we should discuss about these APIs. So first will be this setup API, where the uh, where the where the publisher will set up my messaging, right? Where he will say that basically what is the priority of my messages, right? And then who like yeah, basically priority of the messages, and like some ID, right? That I will be so some this will be a user ID, which will be the client ID, and and so basically he will set it up that I want to set up a new messaging service, and I am the user, and my message priority is this. So for those requests, I will store this information somewhere in my metadata table, that that this is the that this user is looking for this priority ID, and I will return him. So this is the request, and in response I will return him, okay, like kind of this is the messaging ID service that I'm going to give to you. So next time when the client actually want to send the message, he will be using this message ID. So basically this message ID will represent that what kind of messages and all that information you are sending, and then with that he will be sending the message, right?
Yeah, but yeah, I mean, either we store, I mean, as you mentioned, we can store it in the metadata, or else the same client can make, I mean, can send notifications for a different priority level. So can we have it in a single, I mean, let the client decide what kind of priority they want in the request?
So are we saying that I mean for it the priority could be changing for each message?
Yeah, I mean, we can specify that.
Okay, so in each, but like I mean we would have to group those things together in one place, right? That for this user ID, he's going to send these kind of messages with this priority, right? And then I think because like basically if a client is using a banking system, OTP system as my service, and let's say he's also using the sales marketing promotion as my service, right? So like the system which I'm thinking of building is that he will initially set up that, hey, I have to build a service for sales, and then I will return him this message ID. Okay, that if you're building the system for this kind of, then you are getting this ID that let's say it is a sales and cross your user ID one, right? Whenever now he's sending the message, then I can look up that, oh, these kind of messages are of this priority and they belong to this user. So whatever queue I have maintained for these kind of messages, I will be putting the messages in that queue, so that I can order them, right? So I will build so for each message ID, I will build a different queue, right? These queues will be independent, and I will be putting the messages in that queue so that they are ordered. Similarly, if a user is uh, using my API for different kind of messages, then they will have different message ID, and I will use a different queue. Now, when you want to put the messages in the queue, you will just specify the message ID, and I will know, and I will put the messages in that queue. Otherwise, otherwise, if every time you are specifying the priority, but like are you understanding, like with just the priority, I don't know, because for this user ID, let's
Yeah.
say I have one queue of priority 0, I could have another queue of priority 0 for the same user, right? And now if a message comes and if he says that it is priority 0 message, like for these sales also, like it could be a sales, let's say P1 queue, and it could be a marketing P1 queue, right? They both are different. So the messages within this queue should be ordered. The messages within this queue should be ordered. So now if for every messages, if I'm just specifying the priority, I don't know that in which queue this message should be put.
Um,
Like I'm saying that what if a client wants to build different queues which are both low priority, but they are different queues, like the messages between those queues should be ordered between them but not among them.
yeah, basically, if you are talking about Kafka here, right?
Mm-hmm.
So for Kafka, we can just simply put this message in the Kafka topic. So
Mm-hmm.
I don't see the need here for creating a separate queue for each um for each a different user here.
So yeah, no, I'm saying, so yeah, so what you're saying that I'll put the message in a Kafka topic. How would I know that this message should be kept in a new Kafka topic or an existing Kafka topic? And out of existing Kafka topic, if for a user there are 3 Kafka topics with the same priority, how would I know that in which topic should I put the message?
In that case, basically, when designing, we should have only uh, for each priority level, we should have a single Kafka topic, and then probably different consumers. A slow maybe a consumer one for priority one, a consumer two for priority two, and so on, and that will depend on how high priority things we want.
Okay, okay, okay. Okay. So yeah, okay, I got your point. So let's, yeah, simplify it, and so we are saying let's not spend too much time here. So we are
Yeah.
saying that we are so for each user we will have a priority based Kafka topic, and that defines the unique identity, let's say, and then he will, in the request, he will just specify that this is my priority. So then I will, yeah, so then for each user, so basically I will have some metadata stored that for each user,
Mhm.
uh, this is the user ID, right?
Yeah.
And this is the Kafka topic, right? and this is the priority of that topic, right? And now when the request comes, so I will, so initially, like when the first time the request come, I will set up this metadata table based on how the client has set up the system. And then when the request come, I will look up that for this user, what is the priority of the message, and I will look up the value of Kafka topic from here, and basically I will publish the message in that Kafka topic, right?
Yeah, okay. um yeah, I mean, let's proceed. I'll comment on this later.
Mhm.
So it's
Mhm.
fine. I mean, as long as we know where we need to publish this,
Yeah,
yeah, I would say, we I mean, let's proceed and look at the overall picture, then maybe
Mhm.
we can come back to this.
Yeah. Okay. So basically, I'm saying that this table will give me some information that what Kafka topic I need to publish this message, and I think this storage system, it could be cached, because every time for every message I have to first go here, and I think so this will come in between. So first I will go to this metadata table. So let's call it a metadata table. So let
Yeah,
me,
I mean, let's assume that this information is there as to, based on the priority level, we know
yeah, so
where
this,
to
yeah,
put this data, right?
right. And so then I will have this. So first application will go to this metadata table to find what Kafka topic, right?
Yeah,
And based on that Kafka topic, it will publish the message, right?
yeah,
And I think in the meanwhile, asynchronously, it can also put this message in a DB or something where it will be stored for persistent storage, right?
yeah.
So this is the my client API. Now my subscribers API. So I also have to store the, the information where uh, who are the subscribers for this topic, right?
Yeah.
And so okay, so let's look at the subscriber part. Mm, so, so this was kind of a publisher client, and let's say if I want to use my subscriber, so uh,
Yeah, maybe you can draw the queue and proceed from the queue.
mhm, yeah. So again, I think first there will be this setup where uh, the client will tell this basically who are my subscriber. They will be they will be giving me this information that I want to subscribe to this Kafka topic, and I will be storing that information in some metadata, right? So let's say uh, we are storing this information here. So we will have this information that this topic will be these subscribers are interested in these topic, and then uh, and then so once we have that list, uh, then so we are giving this responsibility to Kafka, right? That so I think during the setup, I don't know, I have not experience using Kafka, but
Mhm.
during the during the setup initially, you will so how does it work? So you specify the AP.
So
So
I'll clarify here a bit.
mhm,
So let's say, the message itself has the information of which user to send.
okay, message itself has that information.
Yeah,
Uh,
let's say it's I mean, there are multiple cases here, right? So it can be a one-to-one, one-to-many. So if it's a one-to-one, the information is pretty small. We can have it in the message itself, and we don't need to look anywhere else. So can we proceed for case by case. And
So, but still, I mean, I think it's hard for message to keep that information, that what are the clients, because to send the messages to that client, you need you need that IP, like you need how to connect to that client, right? All that information. So, uh, I was thinking that for a particular topic, the clients will subscribe that I'm interested in this topic, and and when we set up this Kafka queue during the setup, or like after the setup, we can say that these are the clients interested in this Kafka topic to get the notifications. Uh, so and then I think it is the responsibility of Kafka that whenever a message comes, it has to deliver to those clients, right?
yeah, but
Mhm. So basically, like I will be storing this metadata information here, and also like I will be again making a call to this Kafka topic, that these are the clients interested. This is a new client which is interested in this topic, and now it will be the responsibility of Kafka to basically, I will be storing this metadata information with myself as well, and then I will be uh, sending this information to Kafka, and then Kafka will be sending notifications to this clients, right?
yeah, okay, it can be. I guess we have I mean, just last 10 minutes left.
Mm-hmm.
So can we discuss more about the choice of database here?
The choice of database for what? For this metadata information?
Yeah, metadata, as well as I mean, from application server there are two arrows, one up and one down. So can you?
Hmm. Yeah, so I see that this information, this metadata information, is looking at the number of users, right? Looking
Mhm.
at the number of clients. Uh, so basically, we have to store a very structured kind of information, that for this client, uh, this is the topic ID and this is the priority, right? So I
Yeah.
can store this information in some SQL kind of database, and and like but yeah, but the point is that the SQL database, yeah, or actually not, no, actually not that, like we could actually use this in memory cache kind of databases, because this information is pretty small. This information is not very large, so I can
Mhm.
store like in like these kind of data store Redis cache or something, where this is just some metadata information which is small. So I want to keep this uh, keep this as very low latency, right? And this information does not change very often. So
Mhm.
that's why I can keep this in some kind of cache kind of database, right?
Yeah, okay, that's fine. And the one above that?
So this is my persistent data store, right?
Huh?
And so these, like I could use any kind of data stores which are used for analytic, like SQL data warehouse or those kind of databases, right? Because this is the database where I will have high number of writes but low number of reads, right? Reads will be performed basically probably once a month, or right when I have to do some analytics, or when I have to generate a report that how many messages were delivered, how many messages were not delivered. So
So are you suggesting any kind of NoSQL database there, or um,
uh, I think like SQL database is also fun. Like I don't see a strong use case of a NoSQL database, because the information is highly organized, and and I don't, yeah, so like there are even SQL databases which can be used to store large amount of data, like SQL data warehouse, right? Which is which is meant to store very large amount of data, where like your basically I want my write latency to be low, and I'm okay for my read latency to be high, because reads will not be like the reads system is not happening very often, and it is not very latency sensitive operation. It's like I have to generate some reports and send it to clients, so I can do that offline processing and create those reports. Right.
Okay, so I mean, will the data be distributed in itself? And
Yeah, so yeah, so if I'm using some these database services which can store these large amount of data, then it will be responsibility of them to store the data, distribute the data. But yeah, and if we but the data has to be distributed, because the size of the data is so huge, because every day we are generating 10 GB of data, right? So
right.
this data can definitely not fit on a single machine. So it will be distributed.
Okay, okay. Um, yeah, Asim, actually, there are a lot many topics to discuss. So, do we still have time to continue here?
Up to you folks. You
Okay,
Mhm.
I mean, I'm fine to go. Um,
Abhishek, you want to wrap up or you want to continue another 5 minutes?
Yeah, yeah. It's up to Chaitanya, whatever he wants to do. Like he would have better context. Like what is the questions in his mind? Are those questions something which I can answer in few minutes? Then we can.
Yeah,
Yeah.
sure. Okay. So I'll come back to the client subscriber thing that you have written in blue in the box.
Mhm.
So will your system be sending the messages directly, or is there some kind of third party APIs involved where you will send them message? Sorry, there's a police car here.
Yeah, no problem. So, can you repeat the question?
Yeah, sure. So in the client subscriber model here,
Mhm.
the blue box that you have drawn, so to send a notification, be it SMS, email, or something, so will your system be sending it directly, or will you be employing some third party tools for this?
Uh, so this Kafka will be responsible for sending the message, right?
Not
Kafka.
exactly. So in front of Kafka, let's say we have a consumer that is reading from a particular topic.
Mm-hmm.
So
Okay, okay, right. Okay, yeah. So okay. Okay, so you're talking about building. Yeah, so I think that like the application developer would have to build that consumer, right? So application would have this consumer logic where they will be reading the messages from, like, basically they will be getting the messages from this queue, right? And then they will be processing this messages. I think the consumer will be responsible for deduping the message or something, and then finally showing that notification to the user, right? So, and this thing could be, if it is like a mobile app or something, so this consumer is that mobile app, so that mobile app is doing this part, that this mobile app will be getting the notification, and there it has some logic of deduping, and then finally showing the message to the, right? and and then once it has got, like, it it will be like, once it has got the message from the queue, it will send a response back to Kafka topic that I have got the message, so that Kafka topic can delete the message and not try to redeliver it, right?
okay. Um, Okay, so is there any way here where I can store information regarding when the client initially called the application server, right? The time when my system received this message and the time at which the message was actually delivered. So is there any way we can track this information?
We want to track this information that okay, so okay,
Because it's fine that my system received this information that I have to send this event, right? But actually, when I'm sending the event to the actual user, so this time difference, how can my system find this information?
right, okay. So when I receive the message, right, I think I have I have the timestamp in this system, like either in this DB, and also, yeah, I think this is the place where I'm storing that at what timestamp this message was received.
Yeah.
And when this message was received by client, I don't know, like I don't know exactly the APIs of Kafka Queue, but does Kafka Queue has those APIs where I could fetch that when was this message delivered?
I mean, I don't think so. Let's say on, I don't know, actually there's no pointer in Zoom here. So so the black box that you have drawn, right, for mobile app. So instead of mobile app talking directly to the Kafka topic, let's say if we have some kind of consumer application in between that reads or processes the images, processes the events from Kafka topic.
Oh, okay, okay, okay.
Yeah, I mean, because there we have a direct communication with Kafka topic, which is not there in actual cases. So we have multiple systems in between that actually process this information when a particular message was delivered, not delivered. Because here, um,
Oh, right, right. Actually, yeah. Actually, you're right. So, yeah. So there will be application servers sitting here, right? Like some app which will be taking this message, and it will be like so. There, I will be getting the logs, and then it will be sending the message to to this consumer, right?
right, right. So the black box application server that you drew, so that can also call a third, that will call actually call a third party API, which will further send this message to the mobile app.
Okay, and like, what is the like? Okay, why are we having this application server? Like, what is the advantage of having application server? Why are we not directly talking to the
Yeah,
consumer who?
right. So let's say we want to reprocess the message again, or I mean, we have 24 hours till which we want to deliver the message. So yeah, I mean, there can be multiple use cases for this. I guess we need to wrap up now.
Okay, sure. Yeah. So just like to quickly, like if in quickly 5 minutes, I'll probably wrap up. So one thing, so basically we were building this notification system. So yeah, we were able to build one to many and one-to-one notification system, right? Because the clients can subscribe to these topics, and if it is one subscriber, then that one subscriber will get the notification if there are many subscribers. We have also maintained the ordering because we will be creating different Kafka topic for the message, and we will be storing in that topic, and then Kafka will be taking care of ordering the messages, right? Time to live one day. I think this is something that we can set up in Kafka, that keep the message for one day and after that delete it. So, and we have also archived the messages in some storage for audit. The thing is that client can specify the priority, right? Here we have taken the priority, but in the system that we have built, we have not actually used that priority. So I don't know if Kafka topic, we will be sending this priority to Kafka topic, saying that this is the high priority message and take care of it. Like otherwise, like this is something that Kafka topic has to handle, right? Like the Kafka as a service has to handle that how to deal with high priority and lower priority message, because that is something which is responsible for latencies here. So this is something that we have not discussed in detail, that how this can be done, I see. And probably we need more time for this. But yeah, that's something, yeah.
Yeah, thanks, Abhishek.
Yeah.
Thanks for the detailed discussion. Maybe we can now open up the platform for others to comment on this.
Thank you, Abhishek. Thank you, Chaitanya, for the session. And kudos to Abhishek for jumping as a volunteer on the last minute. So, yeah, appreciate that.
So Abhishek, any reason why you use Kafka, not RabbitMQ?
I have not either used Kafka, I have not used RabbitMQ. I just, that is something which came to my mind. I have always used like some things which are specific to my company, which are proprietary in-house built queues. So yeah, so I don't have experience with, I just randomly I picked this name.
Yeah, one thing Chaitanya asked, one point you didn't answer is how will you send the messages, right? Whether that's in-house or whether it's third party. At that point, you went somewhere else. You want to mention that again? Like, how will you send the messages from the queue?
So yeah, so like my understanding is that these subscribers, they subscribe and then they will get the notification. Now so these subscribe, so by third party, I think like it will be third party, because uh, someone who is using my application, who is using my infrastructure, they will be subscribing to my platform, and then it is their responsibility how to process the message, right? My responsibility is to deliver the message to you. So as a system, my responsibility is that I will deliver the message to you, and now it is your responsibility how you have to process the message. So that's why this part, I thought that it is responsibility of that third party service, because my responsibility will be just to notify you of that message, and now you have to handle it.
So notification can be like a push notification, or is it email notification or SMS notification? What kind?
So yes, so I will be delivering that message in the form of a push notification, and now it's up to the third party, right? That how they want to, like how they want to display it to the client. Either they want to display it, either they want to display it as an email to the user, or like a text message or whatever, right? So that is again the third party's responsibility, that how they want to actually take that message and make use of it. Like if I am building this infrastructure service, my responsibility is just to deliver that message to you.
Okay, thank you.
Yeah, I don't know. I have not actually built this system as such. So if I'm wrong, let me know. And if there is some other
Yeah, you can
suggestion.
just say based on the user preferences, the notifications will be sent. That's it.
Okay.
I had a quick question about the API for the notification system. Did we ever talk about what the request body would look like? What does the request actually contain besides just the message content? I'd assume the priority and user ID. Is there anything else in there?
When we are
Like what?
so
Like
when
what
we are
clients to send it to?
so I'm so sorry. Are you saying that when we are sending the message to the subscriber, what is the API for that, or when the publisher is, or when the subscriber is subscribing?
Just where you had the pointer.
This one.
So you have an application server. Sorry, can you hear me?
Yeah, your voice is breaking.
Oh, I'm sorry. Can you hear me now?
Yeah, now it's better.
Okay, so my question was, you have an application server on the left side in red. There's a box, yeah, right there.
Yeah.
So I was just trying to understand how you hit that application server. Is there an API and what the request to that API looks like?
Yeah, so I think that is the API. So my design was that the API is that first you will set up, and so one will be a setup API, and then the next API will be actually sending the message. So while setting up, like you will be authenticated as your user ID. So you will be specifying that what is the priority of the message, and I will be returning you this message ID that this is the, or maybe I should not call it message ID. I should call it a topic ID. So I will be returning your topic ID that you have got now this topic to which you can send the messages. And then I think later, then the second API is for the client is now they can send the message for this topic. So now they just have to, just give me the topic and the message, and then I will be sending the message, and the priority associated with the topic and everything is already set up in that initial setup phase.
Okay, so the topics you have are by priority, right?
Yeah, the topics are by priority. Yeah.
Okay. I'm not sure I followed the setup part, but that's on me. I think I didn't understand completely. Okay. Did we ever talk about ordering of the messages? We didn't, right? Between what order the messages are sent.
So again, like a lot of these responsibilities were given to Kafka because as I said that there will be one initial setup where you will be returned the topic, and then subsequently you will be sending the messages to that topic. So as long as you are sending the messages within that topic, so to the Kafka API also, I will be sending the messages to that topic, and then Kafka will be taking care of sending the messages in order for that topic, right? And like I don't have to.
If a user, if there are, let's say, user 1 and user 2, and you send a P0 notification to user 1, and then you publish a P0 message to user 2, it doesn't matter if if user 2 gets the message before user 1, right? It just needs to be ordered per user, right?
Okay.
I guess this is also just a question to Chaitanya, who posed the question.
Yes. Okay. Yeah. Right. So, yeah. So for different users, are we going to create different topics, right? Because, yeah, you're right. As you said, that between users, the order does not matter, right? For the same user, the order of message is important because they should be delivered in the same order.
Right. So my only comment about using Kafka for ordering is that ordering is only guaranteed within partitions. So it's fine to have, different topics based on the priority, but within each topic, I think the number of partitions should be at least as many as the number of consumers. So there's something called the Kafka key when you publish a message. When you give a key, a hash is calculated on the key, and then from that point on, as long as you use the same key, the message goes to the same partition and is consumed by the same consumer. And ordering is guaranteed within that partition and consumer group. Does that make sense?
Yeah.
Yeah. So, okay. So like, is there a limit to number of partitions that we can create for a topic? Because if we have,
So the only constraint I'm aware of is that you should have as many partitions as consumer groups, because if you have fewer partitions, you know,
No, you're talking about Kafka, right? Partitions equal to number of consumers.
yes.
No, that's not true. That is, I think, for Kinesis is it is true. Like much shards you have. I have used Kafka. There could be one consumer and 20 partitions. Doesn't matter.
I see. But isn't there is some sort of constraint that guarantees that no consumer will be idle, right?
No, so if you have like say 20 partitions and one consumer, it will go to each partition one by one. As soon as you add two consumer, they will split among themselves. One will take 10, other will take 10. If you add three, then they will split. If one consumer is gone, and then it will go back to this. So Kafka will keep on checking the heartbeat of the consumer and keep on rebalancing.
Okay, I'm probably mistaken then. But
So I think what you're saying, what I have read, it was for the kinesis. There, I think there's some constraint on shard and consumer. So I think a shard is equivalent to partition in kinesis. It's again a streaming technology.
okay, I haven't used Kinesis, so I'm not sure how that works. But to, I think, Abhishek's question for how many, is there a limit for the number of partitions? There is a correlation with the number of consumers.
No, I don't think so. Because we can't make a correlation with consumer, right? Consumer could be anybody. Like I'm a producer, I put my data in 20 partition. I can have team one, which can say I can bring only one consumer, which
I don't,
and there could be team two, which can say I can afford 20 consumers, like 20 instance of my consumer.
no, well, okay, I should clarify. It's the consumer group is different from a consumer, right? You can have how many ever consumer groups you want, but the number of consumers within that group is correlated to the number of partitions.
So let's clarify here.
So
You are
a
saying
consumer group
there
is
could be a topic with 20 partitions, and there is 5 consumer, right? Team one, team one, team two, team three. Let's say 3 consumers. There are 3 teams, and within team one, they can now have a multiple instance of their consumer, right?
yes. So team one is a consumer group, and the 3 instances are consumers.
Yeah. So 3 threads kind of they are running.
Yep.
So that's what I'm telling. That because I have worked on Kafka, so I was a consumer, so it was up to me. I can put 1 thread, 2 thread, 3 threads. Kafka will be able to take care of that.
So each of the consumer will have its own thread.
So okay, let me draw. 1 second.
So let me add. So basically, how Kafka is like Kafka, you have a rules engine where the rules engine will actually say who's the consumer and who is the producer and what is the topic that they're subscribing. And if one topic is there and there are 3 consumers, so it tracks to make sure all 3 consumers are consuming the Kafka message. So if 2 of them are successful and third one is not successful, then it will keep track of the third one, which is not successful, and it will report back.
Hey Abhishek, can I annotate on top of your drawing?
Yeah, I can make it blank so that it's easier. Or you want to annotate on top of this?
Anywhere is fine. I was just asking if you're fine with that. So what I know is, so this could be your Kafka topic, and then there could be some, let's say, 5 partitions, 1, 2, 3, 4, and 5 partitions. And then other side you have a consumer 1 and consumer 2. So first consumer will say, oh, I want to register with this, and whether I want to read from start of partition, read from the start, or I want to read from latest. So that also a consumer can tell. So there could be messages lying here. So consumer can tell, I want to day one, I want to start from the first, whatever is the latest message I have, and then I will keep on building my offset. But I can say, oh, I want to read from the start of the topic. That is also possible. And then I can keep on adding consumer one instance A, consumer one instance B. Kafka would be able to keep on rebalancing. If it is only one instance, it will connect all of them to all the what they say partitions. Let's say if this consumer 2 has couple of them B, it would able to again partition rebalance, like it can give consumer to A 2 partitions and one, so it keep on changing. So that's what I was telling, it doesn't matter how much are there. I have also tried like putting consumer to like more partition more instances. Kafka would able to only then assign 1 to 1, and if there are more it will be as a backup, or it will keep on
So,
idle.
could I ask you a question here? So let's say there's so you have 4 partitions within that topic.
Mhm.
What happens when there's only one instance of C2?
One instance, you are talking about this case, right?
Yes.
Yeah, so it will go and talk to all the partitions. And I have did that. So that's
But
what I'm telling.
okay. Okay. That's not
I don't know
my
theoretically, but
experience.
practically I did that. Because on our non-prod environment, we don't invest so much on the number of instances.
Okay. So that hasn't been true in my experience. Because you assign the partition per consumer within a consumer group, you have one consumer only read from the set of partitions assigned to it. So if you were to have, say, 3 consumers and 2 partitions, one of those consumers is going to be idle.
Okay, so I could be wrong. That was my experience. And that was based on my experience, what I'm telling.
Okay.
And
Though I don't
think
have any practical experience, but my theoretical knowledge, I mean, Kafka says that, I mean, one partition can have only one consumer, but it does not say that one consumer cannot talk with multiple partitions.
I didn't so well. I was trying to differentiate between consumer groups and consumers within the group.
so why not sorry, I couldn't get your name.
Sharanya.
Sharanya, so we generally, is it a good thing, like we can do some kind of presentation on Kafka if in case you are interested? Like that would help us to figure out all the doubts. I'm just putting on the spot. I'm so sorry, but it's okay if you say like could be next time.
Yeah, probably next time.
Yeah, next time, like if you don't want to do, still it is fine.
Okay, I'll think about it and I'll keep you posted.
Yeah, just ping me. I think otherwise we all have some fragment of knowledge. It's always better if somebody comes and prepare and give us a right direction.
Sure.
Because otherwise half knowledge could be really dangerous. It is for me actually.
Sounds good. Yeah.
So going back to the previous question, right? Let's see, is that like one topic per user? If that's the case, we have many users, then we need to create many topics with that. And then also like the user can come and go, right? And the cost of create a topic and destroy it.
I think the suggestion was that we would have different topics per priority.
Yeah, you are right. So I'll clarify here a bit. So generally for Kafka topics, we should have only topics for each priority levels that we design. So I mean, for our use case right now, it was just three priority levels. But let's say based on the pricing models, we can have more priority levels, and each topic corresponds to a single priority level. And based on this priority level, we can configure the consumer speed and so on. So
So
yeah.
if like based on priority, then how do we ensure the order of message per user?
Okay, so I can jump in there. If you were to have, let's say, a P0, P1, and P2 as the topics, and then if you keyed on the user ID, you can guarantee that a given user will receive P0 notifications in the same order. So the guarantee is that notifications of the same priority will be the order is maintained, guaranteed there for a user.
If they are in the same topic, right?
Yes.
No, it doesn't matter what yes, if it's in a topic. So if one user is supposed to get a message each from P0, P1, P2, P3, if they have several P0 messages, and okay, let me redo that. So there's three topics, P0, P1, and P2. And if there's three messages of each priority, the ordering is maintained for a user for each priority. So the between topics, the order is not guaranteed, but within, for a user, the order is guaranteed because the message is keyed on the user ID.
I mean, if that user is like probably subscribing to three different topics, then like I would like, I don't know, but my understanding is that within those topics the order will not be maintained, but within the same topic the order will be maintained. So let's say for the same user, for Abhishek, let's say I had one topic which was listening, which has subscribed to OTPs, and another topic which has subscribed to sales messages, right? So my OTP messages will be ordered, my sales messages will be ordered, but the order between OTP and sale messages will not be maintained, right?
Exactly.
This is what you're
For
saying.
a given user, yeah.
So there could be a
would
case
like
that
to
the same
take
user
a
can end up
pause
with
here.
topic one, and the same user can end up on topic two. Then the order is not guaranteed, right?
Yeah, so I would not say that it is based on user here, but I don't know. Like I have not used these services, but my is that it will be, my understanding is it will be based on the topic. Like for your topic, like I don't know how they internally implement, but basically for I think each topic they will be having the queues, right? And the messages within that queue will be ordered.
So actually not on the topic, actually you should say that, I mean, based on the partition. So a topic may have more than one
More
partition.
than, yeah, if that, yeah.
If more than one partition, so the ordering will not be actually same in all these partition, but within the partition it maintain the order. And Kafka actually log based, so actually it use the val to actually keep these data and use the pointer. Consumer maintain the pointer from where it has to read. So it actually sequentially read that file.
Right. Yeah.
Okay, I think we are almost at 10:30. We can discuss about feedback and then close this thing. Anybody wants to give feedback on the interview in general? Otherwise, I will then hand it over to Chaitanya to give his feedback.
Yeah.
Hey, Chaitanya, are you okay to give your feedback as an interviewer?
Yeah, sure. I can give. I mean, I was just waiting for someone to provide some inputs there, but I can start. So yeah, Abhishek, it was a good interview, I would say. First of all, talking about the positives, the requirement gathering was really nice. Um, Also, the calculations related to all the data persistence and how much storage we need and all. So those calculations were also quite helpful. And you kind of draw your decisions based on those calculations. So it was really nice to see that. Um, Also, I mean, the conclusion that you did in the end, that was also really nice, covering up what, I mean, initially what we discussed and how many things out of them we covered up. So I also liked that part. Now, coming on to the things that I find could be improved. Firstly, um, I mean, whenever we are just writing the requirements, we can always add requirements like analytics, pricing, um, and whether it's a SaaS product, or I mean, what kind of product we are looking at, and so on. So I think this information could have been added. Then I guess, I mean, as you mentioned also earlier, that you were not well versed with Kafka. So generally, wherever Kafka is involved, a lot of topics, or there are a lot of intricacies involved of what to have and what to of what not to have. We could have discussed more about delivery of message only once, more than once, and so on. So I guess, I mean, there was some not much clarity or some confusion related to Kafka, and um, that was um, more or less where um, I mean, things could have been improved. Also, I mean, just as a feedback, I would say, I mean, initially we can just start off with, I mean, you started off with a simple queue initially. So I thought you will go ahead with something like SQS or some other internal messaging queue instead of Kafka. So to simplify things, I guess we can talk about multiple SQS queues for different priority levels instead of jumping on Kafka, because I have seen this a lot of times that, um, I mean, a lot of cross questioning happens on Kafka, and unless we have some practical experience on it, it's very difficult to answer these questions. So, I mean, I always prefer to go ahead with simple things like queues. I mean, yeah. Uh, Apart from that, yeah, I don't have feedback, but yeah, overall it was a good discussion.
So one thing I would like
Thank
to
you,
add is,
Chaitanya.
this is Praveen, is so Kafka is just a mechanism to store the information, right? So in a grand scale of things, you could just mention, Abhishek, is we will store the system into a database directly, and based on the order in which will, if it's priority, then we'll have two tables and put it in priority queue and remove it. So that will eliminate all the Kafka, and then you can modify the answer saying that instead of database, you can also use Kafka or RabbitMQ or anything else later. But then you will not stuck in that point, and because that is just one way to store the information and pull the information out of the queues, correct? So you could have just proceeded, because there's so many other areas that you could have dealt with. And then if the interviewer wants to zoom into that area, then you could have delved into detail like this can be done. Because most of the time we spend on Kafka, um, instead of getting a big picture of what is the request API, how is the request look like, response looks like, consumer request, response, and things like that, we could have dealt more if we could have just glossed or a little bit zoomed out into that queue part and just store that it'll just be two priority queues, high priority, low priority tables will store the data, and it will be processed in the order it comes, right? That way we could just proceed it with that.
Okay. Yeah. Okay. So the suggestion is that just like maybe I could have suggested building my own queues, right? And
Yeah,
those would have been
standard
simpler.
tables. Yeah, standard tables, right? In old school, before Kafka days, you just have two tables, and in the order in which you'll dequeue it from the table. And then once it's done, you'll just put it in the log table. How all the traditional batch jobs or everything are done. And then you can say that this is how we could do it quickly, but in a grand scale of things, we'll use queues or other things. And if we have time, we can get back to that. But then you can proceed to other things, right? There's so many areas that you can pick on.
Okay. Yes, like my thinking was that this makes it more simpler, like just abstracting out that part that there is some queuing service that I'm using to queue the message, rather than like going back and implementing my own queue. Yeah, but I think but as you mentioned, just mentioning the name of Kafka, people have a lot of questions about Kafka, so that could create even more confusion.
Not confusion, but you can just mention Kafka and then draw everything else, and then come back to, if Chaitanya wants you to dig into Kafka, then you can dig into Kafka or application server, right? Whether you want to have load balancers or how do you want to split out. It depends on what the interviewer is looking for. Or first level should be just a 50,000 feet of everything. And then you will zoom into like API level or database level or schema level, whichever ones you want to see. But I really liked your calculation of the data. That's good. Overall, you did good. Yeah.
Just one point from my side. Sorry, Abhishek, I forgot. I mean, I was also expecting more for us to discuss on the consumer side. So most of the times it is not the mobile app directly connecting to the Kafka topic or the queue, but we have systems, many more blocks that we could have drawn before actually the mobile app connects to this. So I mean, as Praveen said, definitely a 50,000 overview and then coming back to each topic would have been helped. But yeah, I mean,
I mean, mobile app is also like behind the application service, right? That application service will be telling like what messages to show. So that's like this diagram does not seem very accurate that mobile app is directly talking. It is also running behind application service.
So actually, I couldn't retain the entire thing. I need to step out. I was getting some phone calls. But what I felt, this is actual perfect conversation I've seen where two engineers are talking, going through different things, coming back and forth. Although we spent some time on some components, but overall I felt it was a balanced communication. It was not interviewer was giving a lot of inputs and candidate is not able to cover up, but it was like I really liked the balanced conversation here. That is my feedback.
Okay, thanks. So Chaitanya, one question I have is, you were talking about that clients can specify the priority of message. So how are we going to build because like were your expectation to build the system around that, or was your expectation that this priority will be given to some queue service and it's the responsibility of that queue service to handle the priority?
Yeah, that's a good question. So generally for any third party notification systems, right? If I mean, once we take their subscription or just be a member, so we get a basically get an auth key or some kind of secret by which we can access their APIs, and their APIs are pretty generic. So when we make a API call, at that time we can specify what kind of priority we want for this message, what kind of message it is, and to whom we want to send it. So especially for OTPs that are for bank related items, so we can specify all this information in a single post request, and the notification system then reads our API key, and based on this it sees it puts the particular message into the priority queue that we have, and then charges us accordingly.
Yeah, so like, and how is the, like, my question was your expectation to just build the APIs, or was your expectation that how actually the system will now handle the priority? Like, because the expectation of system is that whatever resources it has, right, this system has still some limited resources, so it has to utilize that resources in such a way that, given the constraint of resources, it should first try to use the resources for the higher priority messages than lower priority messages, right? So, and to do that, there are these job scheduling services and all, which like, where you specify that, hey, like, this is the priority of my this job, and now like you, and then basically the job scheduler will do all those things that it will do that. So was your expectation discussing all that with the priority, or was your expectation that defining the APIs and then the system is abstracted and it is handling out that priority and job scheduling part?
Yeah, I mean, my main objective was to have a very high level overview of all the components and then talk about the APIs.
Okay.
I think it was the priority from the client perspective, not from the system perspective, right? Priority of the message. Is that the question?
So, no, but like, whatever client is saying as priority, that maps to how system is handling, right? So basically, the, like, my understanding is, so my system has some constraints. So if you have sent me like so many messages, there might be some delay, there might be some queuing happening at my point, where I'm not able to send your message immediately, where I'm not able to deliver your message to the subscriber immediately. But given so many messages, how will I decide that which messages should I be delivering first, which messages are high priority that then should be delivered sooner? That is something that the system has to handle, right?
Yeah, but that would be not involve the client, right? The client should know that. The client, from the client point of view, I think the message would say, okay, this one you can deliver it, but it's low priority, so you can deliver it like, sometime late. It doesn't matter, but this one high priority, so I want it delivered as soon as possible.
Yeah.
And I also I also have another question, like Abhishek, you was talk about the consumer get the message get pushed to the consumer, right, at some point. And let's say I have the message, and then that message should be delivered to 3 consumers. And what happened if it successfully delivered to 2 consumers, and the 3rd consumer is down of some reason, it's not there, then what the system needs to do?
Yeah. So like, my system was that for one day it will keep on retrying, and that retrying could be like it could keep on retrying after some exponential back off or something. And if the client is not up after a day, then the message will be deleted from the queue and I won't retry anymore.
So the system will also need to keep track of this message still need to deliver to which consumer, right? Type a pair. this message for this consumer because all the consumer already successfully consumed.
Right. But I kind of abstracted out to the queue, that queue, whoever are the subscribers of that topic, queue will be taking care of it, that every subscriber should get the message in that topic, and queue will be retrying to deliver that message in that topic to each of the subscribers. So the queue will be maintaining that mapping, what mapping you're talking about, that for each of the subscriber I want to deliver the message.
Does anyone know how retries work with RabbitMQ? Or has anyone had experience using RabbitMQ in practice? I think somebody mentioned that one of the first questions was why Kafka over something else like RabbitMQ?
Yeah, I think Praveen asked that question, yeah.
Hey, can you hear me?
Yes.
Yeah, so basically, we have Kafka has a retry mechanism, at least in what we do in our companies. We have a retry mechanism of 3 times, and after it is not consumed within 3 times or within certain amount of time, we can have that logic, and then it will be we write that backup uh, into a database, and then once customer comes and says that hey, or he didn't pick or something happened, then we'll republish the events back into the Kafka queue. And we also have Kafka, and we also have RabbitMQ. So based on different scenarios, we move the data from Kafka to RabbitMQ, and then once after RabbitMQ is also not there, then we write that back to MySQL database for auditing to see why the consumer didn't consume the data.
Would you mind explaining why you would choose RabbitMQ, or like in which case you would use RabbitMQ over Kafka? And I'm asking because I've never used RabbitMQ before.
Yeah, basically it's because of the performance of Kafka is pretty good, and reliability is good for this one. What is the other one? RabbitMQ, and I'm blanking out.
So in Kafka, there is one more thing.
Yeah.
There is one thing like if you don't commit, it keep on retrying. So basically, like Praveen mentioned, we need to either have a retry mechanism or read the message if it didn't work, retry within that, or like there are two ways you can retry. You can read the message, the same thread can retry, or don't commit it. It would be picked up by the consumer again.
And one thing is Kafka is very fast, so that's why most of the people use Kafka. RabbitMQ is more stable, but it is inherently a little bit not that fast. So people generally use that for more stable thing, but high performance generally they use Kafka.
So, so anybody knows like if RabbitMQ is a streaming one or just a queue? Because Kafka is streaming.
I think both can be configured that way.
What do you mean
But
by streaming and queue, Asim?
So it could be, it is just my understanding how I interpret it. So Kafka could have multiple consumers. It tracks like there could be multiple consumer groups. But for a queue like SQS, there could be only one consumer. It could not track whom. So if it has one message, it could not track I have given to 10 different consumers. So in that way.
I believe that. I mean, though I don't have any practical knowledge in any of these systems, but based on my reading, so RabbitMQ actually you can push to multiple consumer.
Okay, so
Only,
then
only difference I do understand between Kafka and RabbitMQ is that the RabbitMQ does not guarantee the order.
okay.
Because
So basically, multiple consumers can be, multiple consumer groups could be possible for RabbitMQ.
Yeah.
Yeah, there's subtle differences that you can search online, but our implementation is we used Kafka first, and then we used RabbitMQ, and then if both doesn't work, then the final backup is we save it in the database, and then we'll if consumer doesn't ask for request, we'll purge it from the database. If the consumer asks, then we'll re-push the data back into the queue, Kafka queue.
And Kafka is actually pull use the pull mechanism, but RabbitMQ use the push.
Okay, I think we are almost there, and we can wrap up. So I think Chaitanya already left. So great job, Chaitanya. Kudos to Abhishek for jumping in the last minute. And as a candidate, it's always a tough spot. So yeah, much appreciate that.
Yeah, thank you so much, everyone.
Hopefully,
For
like
your
we all
feedback.
have learned a lot of things today. At least I have learned a couple of new things.
Yeah, thanks,
Right.
Abhishek. Yeah, thanks, Chaitanya. Also, it was a great interview, great session. Yeah.
I'm going to stop the recording.